So once again, we're going to go over this practice test. We're not going to go over the whole thing. If you want everything explained, please watch the previous videos that are uploaded to Edmodo. It says right here that you're going to have 3 where you factor out the GCF. So I would put parentheses right below it, and you look at what's in common in all 3 terms. So let's start with the coefficients, the numbers. Well, there's definitely a 2 in common in all 3 terms, but is there a greater value because you want to pull out the GCF? So 6 is definitely the best number. Now, how about letters? Is there A's in all 3 terms? No. Is there B's in all 3 terms? Yes. How many B's? There's the maximum amount of B's you could pull out from all 3 of them at the same time is 5. So we're pulling out B to the 5th. So the GCF is really 6B to the 5th, right? Now, what would be left over on the inside? It's kind of like doing reverse distributive property. 6B to the 5th times what will get us this first term? And let's start with 6 times 4 is 24. So I'm going to put a 4 right here. And then B to the 5th times what will get us an A, B to the 9th? Well, you definitely need an A right there. And you also need a B to the 4th. That way you could add the 5 plus 4, the 5 plus 4 giving you the 9. So that's the first term. Let's do the next one. 6 times what will give you 12? 2A. Positive 2, okay. And you're right, we also need an A, so we need an A right here. Let's put an A right there. And do I need any more B's? No. B to the 5th times 1 will get you B to the 5th, but we don't actually put a times 1 because a times 1 doesn't change anything. Okay, and then last but not least, 6B to the 5th. 6 times what is minus 18? Minus 3, that's right. So let's put a minus 3, and then B to the 5th times what will get us B to the 6th? I need one more B, right? So yeah. And that's your final answer for this question. There's going to be 2 more of these guys. And, you know, pulling out the GCF is the first method we learned on factoring. It's the first method you should always try. And then you look at the inside and you try to continue working, but there's nothing else to do on the inside. There is no perfect square quadratic trinomials. There is no A times C because you have 2 variables, right? So there's nothing else to do. Let's jump down to here. There's going to be 4 of these guys. 4 of the super easy, all you do is recognize that there's a 1 right in front of here. So you could jump right into this. And you think, what times what is negative 48? That if you add together is negative 13. Again, what times what is a C value? That if you combine together is a B value. And the best way to approach this if you're stuck or if you're not seeing it right off the bat is to make a list, right? You make a list. So negative 1 times 48, negative 2 times 24, negative 3 times, I believe, 16, negative 4 times 12, negative 6 times 8. And that's about it. And of course, if you're struggling with multiplication, use a calculator. You can say 48 divided by 2, it'll give you the 24. 48 divided by 3, it'll give you 16. 48 divided by 4, it'll give you the 12, and so on and so on. Anyway, which of those pair of numbers, when I combine together, does it give me a negative 13? Negative 3 and 16. If I combine these guys, a negative 3 and 16, that'll give me a positive 13. And we know we want a negative 13. So we have the right numbers, we just have the wrong signs, right? So let's change that negative 3 to a positive 3 and change that 16 to a negative 16. So once you figure that out, you simply plug in those 2 values, the plus 3 right there and the minus 16 right there, and you are done. So like I said, you're going to have 4 of those, and they're really easy. You should be happy that you have 4 of those. Now there's going to be 2 factoring by grouping. There's going to be 2 factoring by grouping. So what we should be doing here, especially if there's 4 terms, is to separate them into 2 groups. That's step 1. 3c squared minus 6c, leave some space, minus 2c plus 4. And then put parentheses down here because you're going to factor out the GCF of the first group. So what's the GCF on that first group? 3 with a c. So 3c is your GCF. And if I pull out a 3c, what would be left on the inside? In other words, 3c times what will get you a 3c squared? A regular c, right? Regular c. And then how about 3c times what will get you a negative 6c? A negative 2, correct? And now let's look at our second group, and let's see what we could pull out of that second group. What's in common in the second group? a 2. So let's pull out a 2, but better, let's pull out a negative 2. Now, the reason why I say negative 2 is because if I pull out a regular 2, there's still going to be that negative sign, and that'll be a negative c, but we want a positive c. Remember, we want the binomials to be common. So if you pull out a negative 2, it really will give you a positive c right here, because negative 2 times what gets you a negative 2c? That would be a positive c right there. And then negative 2 times what will get you a positive 4? A negative 2. And now you take a step back, I want to zoom out a little, and you recognize that there's a common binomial. There's a common binomial right here and right here in both groups that I'm going to factor out. So I'm going to pull out that common binomial of c minus 2. And what would be left on the inside? The 3c is left on the inside, and also the minus 2 is left on the inside. So we have factored, here's the factored form answer, c minus 2 times 3c minus 2. That is your answer. Do you get it? I hope so. So there's going to be 2 of those. They do take a while. Sorry. There's also going to be 2, and I think maybe even 3 questions where we have a quadratic trinomial where the a value is other than 1. So you can't just jump right into this. You can't jump right into that and think what times what is a c value that if you combine together is a b value. That's incorrect. Why? Because there's a 12 right here. So instead of m times m, it's going to have to be something like 3 times 4, or maybe like 2 times 6, or maybe like 12 times 1. I mean, who knows? That's why we have to use the long method. So what do I mean by the long method? Let me erase this first. Step 1 would be to multiply a times c. So let's all do this together. Step 1 is to multiply a times c. And a is 12, and c is negative 6. So what's 12 times negative 6? Negative 72. Okay, that's the answer for step 1. Step 2 is to make a list of the multiples of that answer, negative 72. Just use a calculator, right? Negative 1 times 72, that's easy. Negative 2 times 36. Negative 3 times, oh, you're already saying the answer? 9 times 8? 9 times 8, negative 9 times 8, or negative 8 times 9 is the correct pair of numbers. But just to let you know, you could make this list with the calculator easy. And of course, if you get all the way to 8, negative 8 times 9, that will give you 72. And if you combine these together, it really will give you the middle value b, which is positive 1, right? So that's the correct pair of numbers that we want. You might see it right off the bat, or you might have to make the entire list and then go through and start adding all that. Add that, that gives you 71. Add that, that gives you 34. And then once you get to here, it'll be like, oh, combine that, that gives you 1, and that's the one we're looking for. Now from here, it's pretty easy if you use that magical shortcut. Plug it into AX, right? In other words, whatever value you have here and whatever letter you have there. In this case, it's a 12m. Put 12m on both. And then you take this pair of numbers from step 2 and plug them in right here. So you're going to take the negative 8, plug it in there, the positive 9, plug it in there. Let's do that. Negative 8, positive 9. And then here's that was step 3. That was step 3. Let's go for the 4th magical step. The 4th magical step is to just magically divide each of the binomials by the biggest value that you can. So if you look at 12 and 8, you don't want to divide by 2 because there's a bigger value. What's a bigger value you could divide both by? 4. So again, we are magically dividing by 4, and you'll get a 3m minus 2. If you we're not factoring out a 4, we're just magically dividing by 4, right? Now let's look at the other binomial. What could I magically divide both of these by? 3. So if I magically divide both of those by 3, it'll become a 4m plus 3. And guess what? We're done. So, I mean, this is probably one of the hardest type of questions there is, but once you practice it enough, it becomes easy, right? Again, step 1, a times c, the first one times the last one. Get a number. Step 2, make a list of the multiples of that number. And then find out which pair of numbers combines together to give you the middle value b. After that, you plug in your ax term, in this case 12m, you write it twice, and then you take this pair of numbers, plug it in, and then magically divide both to get your final factored form. All right, let's look at the back side. The back side, there's going to be 3 to 4 questions on factoring perfect square binomials and trinomials. Now, perfect square binomials and trinomials, I love them, right? Whenever you notice that you have a perfect square term in the front and a perfect square term in the back, you might be able to jump right into your factored form and take the square root of this guy, which is what? What's the square root of 25x squared? 5x. So you put 5x as the beginning part of both binomials. And then what is the square root of 4? 2. So you put that as the second part of both binomials. And now you need to determine, you see, the last if you distribute, the last distribution is going to be 2 times 2, which gives us 4, right? But the positive 4, when you go 2 times 2, it gives you 4. It could be positive 2 times positive 2, or it could be negative 2 times negative 2. It can't be a positive times a negative, because that wouldn't give you a positive. So are these both positives, or are they both negatives? They're both negatives because the middle term is negative, so that negative has to come from somewhere. Both of these have to be negatives. You can't say that one of them would be negative and the other one positive, because that would eliminate the middle term. I hope that makes sense. So both of them have to be negative. Now, you're supposed to try and double check and see if it works, right? So just quickly, what's 5x times 5x? 25x squared. So far, so good. 5x times negative 2. Negative 10x. And then negative 2 times 5x is another negative 10x. And when you combine those two negative 10x, it really does give you the negative 20x. All right, so we've double checked it. You don't have to show your work when you double check. So that's how we're going to be doing these guys, right? Some of them, like check this one out. You can't just take the square root of that because it's not a perfect square term. So what should you do first? Always. What's the first type of factoring you should always try? GCF. So what would the GCF be if on these three terms? What could I pull out? Could I pull out an 18? No, that's not going to work. How about we pull out a 2? That's right. Pull out a 2. What would be left on the inside? 9x squared plus 42x plus 49. Now, ladies and gentlemen, look at the blue quadratic trinomial on the inside. Okay, the blue quadratic trinomial on the inside, you could still work with that because that is a perfect square quadratic trinomial on the inside. So let's try to square root it and plug it into our answer format. What's the square root of 9x squared? 3 with an x. Put it on both beginning parts of both binomials. And then how about the square root of 49? 7. Put that as a second part of both binomials. Now notice, what symbols do I need here? Plus is both. Why? The whole thing's plus, so all of it's plus. So put a plus right there and a plus right there. Don't forget to bring down the 2. And ladies and gentlemen, we're done. This is your answer. Full credit if you write it that way. Also, if you wanted to make it smaller and nicer, you could write it like this. To the second power. Okay? So you might have to pull out a GCF before taking the square roots. I mean, technically you're supposed to double check it, right? 3x times 3x, 9x squared. 3x times 7 is 21x. 7 times 3x is another 21x. 21 and 21 really is a 42. Just to quickly double check it. Just because you have a perfect square term in the front and in the back doesn't mean that you're going to be able to square root them. So like this guy, it looks like I could square root that, which I can. It looks like I could square root that, which I can. So some of us are thinking, well, yeah, then my answer is going to be what? 9x plus 5 and 9x and another 5. Now, if it's a binomial, then that means that the middle term would have to cancel out. Since there is no middle term, one would have to be positive, one would have to be negative. But if I do put a plus here and a minus there, at the very end, a positive 5 times a negative 5 is not a positive 25. So this does not make sense. This is no good. This is what we call prime. It's not factorable. Okay? So right there, it's prime. It's not factorable. The only way that you could actually square root it, and get a binomial is if this were a minus. I don't know if you guys remember the title of the section. It was called Difference of Two Squares. Now, difference means subtraction, not addition. So the only way you could do the difference of two squares is if there's an actual subtraction right here. Anyway, could we do the difference of two squares on this one?
Yes.
Yeah, there's a minus sign, right? And they're both perfect square terms. So, I mean, it's easy. What's the answer going to be? What's the square root of 81x squared? 9x. What's the square root of 25? 5. And of course, that's a negative 25. So what signs do I need between them? 1 plus, 1 minus. That's it. We're done. Easy peasy lemon squeezy. Now, the last 5 questions on the test. The last 5 questions on the test are solving. Okay? So I don't want to see this on the last 5 questions. I don't want to see this or even any type of factor. I don't want to see that either. All I want to see are some answers, right? I want to see x equals 3 or x equals, I don't know. I want some answers, right? Solving, you want answers. You do not want to leave it in factored form. You can't get credit for that. So what do we do when we're asked to solve? Well, you want to factor it. That way, if it's set equal to 0, you could split it and solve. Okay? So I want to factor it, but see, this one's already factored for me. Okay? It's already in factored form. The parentheses are there. So I really do have something times something that gives me 0. So the first something could be 0, 7x minus 8, that could be 0. Or the 7x plus 21, that could also be 0. So I need to solve both of these simple equations. You're able to split them because of zero product property. Now, if you didn't have a 0 right here, you wouldn't be able to do it, right? So anyways, let's solve. Add 8 to both sides. You're going to get 7x equals 8. Final step would be to divide by 7, and that's your answer. X equals 8/7. The other one, let's subtract 21. We will get 7x equals negative 21. We're going to divide by 7, and final answer is x equals negative 3. Negative 21 divided by 7 is negative 3. You have to write both answers to get full credit. If you only write one answer, you only get half credit. That's no good. It's 50%. Nobody wants 50% F. So if it's factored, all you have to do is split it and solve, especially when it's equal to 0. But look at this one. This one's not even equal to 0. So you can't even factor yet. You need to first set it equal to 0. So let's do that. Let's subtract 10x. Subtract 10x. You can't really subtract 10x from those, so let's rewrite it. There it is, rewritten. And now we need to factor, split, and solve. Try different ways of factoring. Could you pull out a GCF? No, you can't. Is there any shortcuts? Like, is this a perfect square term and that a perfect square term where you could square root them? No, you can't. So once you exhaust all the possibilities of factoring, then you go, okay, I guess I need to multiply a times c, right? A is 8, c is negative 3. So let's do step 1. A times c. We're going to end up with negative 24. That's your answer for this first step. Second step, make a list. A list of the multiples of that number, negative 24. Negative 1 times 24, negative 2 times 12, negative 3 times 8, negative 4 times 6. Those are all the possibilities. Now, which pair of numbers combines together to give us the middle value, b, being negative 10? So which pair of numbers combines together to give you a negative 10? 4 and 6, does that give you negative 10? Oh, 4 plus 6 is 10, but this is not a 4 plus 6. This is a negative 4 plus 6. When you combine these guys, you get a 2. 12 and negative 2. 12 and negative 2. When I combine 12 and negative 2, what do I get? Do I actually get a negative 10? No, I get a positive 10. So I have the right numbers, I just have the wrong signs. So switch it to a positive 2 times a negative 12, and then you're good. After that, you want to use the magical method, right? Where you set up AX. What is AX? 8x. So let's write 8x 2 times. And what do we do with this pair of numbers from step 2? We plug them in. So you're going to put the plus 2 right here, and you're going to put the minus 12 right there. Now, that's barely step 3. We still need the fourth magical step, which is to magically divide both of these by a certain value, and then magically divide both of these by a certain value. So what are we going to divide both of these by? 2. So we're going to end up with a 4x plus 1. And what am I going to magically divide both of these by? 4. So I'm going to magically divide by 4, and I'll get a 2x minus 3. This is completely factored. We're done factoring, but it's still an equation with an equal 0, so I still need to bring that down to equal 0. This is probably one of the hardest questions there is on the test. Now, once I have this, now that it's in factored form, I could use zero product property. If something times something gives me 0, then the first something could be 0, or the second something could be 0. So let's solve both. Minus 1, minus 1. We're going to end up with a 4x equaling negative 1. Final step would be to divide by 4, and there's your answer. X equals negative 1/4. Now do the other one. We're going to go plus 3. We're going to end up with 2x equaling 3. Final step would be to divide by 2. So the other answer is x equals 3/2, or 1.5. But I would leave it as an improper fraction, 3/2. That is as hard as it gets. Look at, it is a lot of work. It becomes easy when you practice. Let's take a look at another one. So looking at this one, it's the same type of process. First, add 1m, move it this way. Subtract 6, move it this way. It'll be set equal to 0. And then you're going to have to go through all those long steps that we just went through over here. Okay, that's more practice for you. You might have a super ridiculously easy one like this one, where you have something squared equal to a value. So there's two ways of doing this. One is to apply a square root to both sides. You will get x because a square root gets rid of a square. And you end up with a plus or minus in front of the square root of 9, which is 3. If you don't put the plus or minus, it's going to be incorrect, right? If you understand that, that's great. Is there a different way of doing it? Yeah, you could have, if you wanted to, you could have subtracted 9 and ended up with x squared minus 9 equals 0. And then you could think, oh, x squared minus 9, I could rewrite that as x plus 3 times x minus 3. And then you could split them and solve, and that way you'll get the plus 3 and the minus 3 as well. So it's just two different methods. I would go with the square root. It's faster. Let's take a look at this guy over here. There's many ways of doing this also. What do you guys think? Do you want to apply a square root? Yes. Apply a square root? Okay, so what would you do first here? What would you do? Okay, so if you want to set it equal to 0 to factor, split, and solve, we could do that. You know what? I'll do both methods. So let me subtract 121. I'm going to rewrite it. It's going to be 144 144x squared minus 121 equals 0. Okay? And now I could factor because I have a perfect square and I have a perfect square, and there is a difference of those two squares. So I could use a shortcut by square rooting 144. I'll get 12 with an x. So you put that 2 times at the beginning of your binomial. And then the square root of 121 is 11. So you put 11 on both second parts of your binomials. And because there is no middle term, they have to cancel out. One has to be plus, one has to be minus. Now it's still equal to 0, so you could split them and solve, right? So you could split them and solve. So we're going to have 12x plus 11 equals 0. 12x minus 11 equals 0. So when I subtract 11 and subtract 11, I'll get 12x equals negative 11. When you divide by 12 and divide by 12, you're going to get that answer, x equals 11 over 12, but negative. So x equals negative 11 twelfths is one answer. And if you do the work on this other one, it'll be x equals positive 11 over 12. Sorry, I didn't show all my work there. That's one way of doing it. Here's another way of doing it, which I prefer. Check this out. What if right at the beginning, let me do it in blue, if I would have gotten the x squared by itself by dividing by 144 and dividing by 144. Then you'd have x squared equals 121 over 144. And then you could apply a square root to both sides to get rid of this square. But when you apply a square root in an equation, you have to put a plus or minus in front of your answer. So all you need to do is split the root, 121, 144, and you'll get x equals plus or minus 11 over 12. So you get the same answer. It's just a lot faster, I think. So those are two different methods. It's up to you. So this guy is ridiculously easy as well. Why? Because there's a square, and to get rid of a square, you do the opposite of a square, which is a square root. What you do to one side, do to the other side. What would you have left? X minus 9 equals, you need a plus or minus in front of your answer, which would be 12. The square root of 144 is 12. So for your final step, you'd have to get rid of that minus 9 by adding 9 and adding 9. And for me, to make more sense of this, I like to rewrite it. X equals a positive 9 with a plus or minus 12. And then from there, I would do my positive situation, 9 plus 12, and my negative situation, 9 minus 12. So 9 plus 12, that's 21. 9 minus 12, that's negative 3. So those are your two answers to this one problem. I know I went really fast. I'm sorry about the long video, and I did skip a couple of questions. You need to have this whole thing complete by tomorrow.